Imagine you're working with a KTP700 basic HMI connected to two PLC 1200s. You've designed variables for each PLC, labeling them Me1 and Me2. Now, here's the challenge: certain variables across these two PLCs need to maintain the same value. The question is, can these variables be synchronized in individual fields? This isn't just a trivial task, it's crucial for maintaining data consistency across your system. And here's why that matters: inconsistent variable values can lead to operational errors, system failures, and increased maintenance costs. So, let's dive deep into understanding how we can achieve this synchronization without compromising system integrity. Understanding how variable synchronization works between two PLCs is crucial. Imagine each PLC as a separate entity with its own memory and processing capabilities. When you want to synchronize a variable across both PLCs, you're essentially creating a link that updates both PLCs with the same value. This is done by using an internal variable within the HMI that acts as a mediator. When this internal variable changes, it triggers an event that writes the new value to both PLC variables. The key is to set up this internal variable correctly and ensure that the event handling is properly configured. This way, any change in one PLC's variable will be mirrored in the other, maintaining synchronization. Now, let's dive into setting up the internal variable and the event trigger that will synchronize the variables across both PLCs. First, create an internal variable in your KTP700. This variable will serve as a bridge between the two PLCs. Name it something meaningful, like synchvar. Next, assign this internal variable to the fields in your HMI that need to display the synchronized value. Then, set up an event trigger. This trigger should fire whenever the value of synchvar changes. To do this, go to the Event Configuration menu, select Variable Change, and specify synchvar as the variable to monitor. When synchvar changes, the event will execute a script that updates both PLC variables to the new value. This ensures that both PLCs always have the same value for the shared variables. Now, let's dive into the practical execution of writing the internal variable value to both PLC variables. First, you need to create an internal variable in your HMI project. This variable will serve as a temporary storage location for the value you want to synchronize. Once you've created this internal variable, assign it to a field in your HMI interface. Next, set up a change event for this internal variable. When the value of the internal variable changes, you'll trigger a write operation to both PLC variables. Ensure you use the correct data type and format for the variables to avoid any data mismatch issues. And here's a pro tip: always test the synchronization with different values to ensure reliability. This method not only synchronizes the variables but also enhances the overall efficiency of your system. And here's why that matters. When you're synchronizing variables across two PLCs, there are subtle nuances that can make or break your setup. One common edge case involves timing discrepancies. If one PLC updates its variables faster than the other, you might end up with inconsistent data. To mitigate this, use a timestamp mechanism. Each time a variable is updated, append a timestamp. This way, you can compare timestamps and ensure you're always working with the most recent data. Another consideration is network latency. If your PLCs are connected over a long distance, network latency can introduce delays. To counteract this, implement a buffer mechanism. Store multiple recent values and use the most recent one available when needed. This ensures your system remains responsive even under less than ideal network conditions. Remember, the devil is in the details. These small optimizations can make a huge difference in the reliability and performance of your system. Now, let's dive into common pitfalls you might encounter when synchronizing variables across two PLCs. One frequent mistake is neglecting to properly configure the internal variables. Remember, you must assign the internal variable to both PLCs and set it as the event trigger for changes. Another common error is overlooking the importance of the correct data types. Ensure that the variables you're trying to synchronize have compatible data types to avoid runtime errors. Also, pay close attention to the communication settings. Incorrect baud rates or timeout parameters can lead to failed transmissions. To avoid these issues, double-check your settings and test your configurations thoroughly before deployment. This meticulous approach will save you from potential headaches down the line.